is on momentum with calculus. Question 1. The momentum of a particle is given below. Find a formula for the force exerted on the particle. So we need to memorize this formula, F equals dp dt. So just take the derivative of the momentum and we can find a formula for the force. Same thing with part B. The derivative of sine is cosine times the derivative of 6t. So that's exactly what we get here. Question 2. Given momentum equals 3t squared plus 18, part A, find a formula for the force. We're going to use the equation F equals dp dt to get 6t. Calculate the value of the momentum and of the force at t equals 2. So momentum is a function of time. Force is a function of time. So just plug in t equals 2 for each one. Part C, find the average force between t equals 1 and t equals 4. So the average value, take F at t equals 1 plus F at t equals 4 and divide by 2. Part D, find the average momentum between t equals 1 and t equals 4. So the average momentum, we're going to use this equation here. It's an integral. Question 3. A particle whose mass is 7.5 kilograms is initially at rest. It is now subjected to a force whose equation is F equals 18t. Find the velocity at t equals 5. So F equals dp dt, we multiply both sides by dt and we integrate. And we know P final minus P initial is mv final minus mv initial. V initial is 0 because it was initially at rest. Part B, find the change in momentum from time equals 2 to time equals 7. This is the equation for change in momentum. Question 4. A particle with a mass of 3 kilograms is subjected to a force given by F equals 24t. At t equals 7 seconds, the velocity is 250 meters per second. Calculate the initial velocity. So once again, F equals dp dt, multiply both sides by dt. We're going to integrate F dt to get 588. P final minus P initial is mv final minus mv initial. And we have this initial condition. At t equals 7 seconds, the velocity is 250. So that's why we're going to go from t equals 0 to t equals 7. And we could solve for v initial. Part B, calculate the change in momentum from t equals 2 to t equals 5 seconds. The change in momentum is P final minus P initial. We were given F, it's here 24t. And we're going to integrate this from t equals 2 seconds to t equals 5 seconds. Now we're solving for delta P, which is P final minus P initial. Question 5. A particle is subjected to a force from t equals 1 to t equals 5 whose equation is given by F minus 24 equals minus 6 times t minus 3 quantity squared. calculate the impulse. So the impulse is F delta t, which is equal to delta p. So for this equation, multiply both sides by delta t, or dt, and take the integral. And that's exactly what we do here.